They might be small, but if they go wrong, they pack a heck of a punch. With all the phones, laptops, cameras and tablets, the average airliner could have 500 lithium batteries on board. Most are regulated and safe, but Britain's safety watchdog, the CAA, is warning people about untested, counterfeit batteries you might buy online. Well, you saw how dramatic that was. It was just a normal laptop battery. There's the before, and there is no after. It's completely disintegrated. Just imagine something like that exploding on an aircraft. Well, David, we saw how spectacular that explosion was, a series of explosions. It was just a normal laptop battery.
Absolutely.
So what do you do then if you see one of these smouldering?
If you see it smouldering, then it's a sign that there's this thermal runaway reaction that's starting to occur. Now, what we've done today is force that reaction to take place potentially more quickly than would otherwise occur. And obviously, normally that reaction occurs as a result of a fault that's been built into the battery.
So we've recreated a faulty battery there?
Yes. This isn't representative of how every battery is going to behave. It's certainly not an indication of what to expect from your run-of-the-mill batteries. They normally go through quite extensive quality control procedures, and that should remove these sorts of issues. It's a very low probability event, in other words, but the hazard, as we've seen, is potentially quite drastic. There isn't much that anyone can do about if it does explode in the way that we've seen, then you're not going to be able to react to it in that sort of timescale. If you start to see it smoking, then what you need to do is take the energy out of that battery as quickly as possible, and that really means applying water. Never apply water onto a device that's plugged into the mains. That advice still stands, but where the battery is standalone and it is self-contained in this way, you should apply water onto it, get the energy out of the battery, and dissipate that energy that's otherwise going to lead to this potentially explosive result. What our general guidance is around electrical fires is not to use water because there's a risk of electric shock. But with batteries such as this, the guidance actually is to use water because you take the energy out of the battery, you slow or even stop that reaction from occurring and hopefully stop it from going into the explosions that we've seen. If it does explode and it's still burning, then equally apply water as quickly as possible and get it put out, get the energy dissipated out of it and reduce the risk.